Welcome to another GC Basic demonstration. This is for the PIC16F legacy chip family. This also applies to 10Fs and 12Fs. So what I'm showing you here, if you've got enough pins on a smaller device, go do it. But this is part 13 using SPI. And for SPI, I'm going to use a graphical LCD. So it's January 2025. Go get the latest build so that you can do this. Please like and subscribe. Gives it a thumbs up. That means subscribe to the channel and get the latest video updates. Let it run all the way through. Thank you very much. So, number 13. Prerequisites. Gone through this many times. You've got the software installed. You've got a programmer installed. You can program the PIC. You've got some LEDs. Whilst we're not using those LEDs this time, or the pot, or the switches, or the USB, they should be attached to your solution. And you have an LCD and specifically an SPI SSD 1331 GLCD. They're very inexpensive, up on the web, and we'll have a look at one. So SPI is the key to that. Obviously, I'm showing SPI, but it supports other protocols as well. This is the hardware I'm going to be using. There is nothing specific on here that is for the SPI solution because we're going to be using hardware SPI. You can use software, it's up to you. But what I'm going to show you shortly is a photograph of how I've got it attached. But essentially, I'm actually hooking into a couple of connections here, 3 other connections down here, and a ground and 5 volts. So I'm using the pigtail, yeah, for my connectivity. Really quite easy. What am I actually doing? I'm actually connecting up 1, 2, 3, 4, 5 communication ports. You could get away with 3, but 4 for this. 1, 2, 3, 4, 5. 5 for this. SPI. Now I'll explain what they are. SDO is serial data out, serial clock on port 3, a reset, a CS, and a DS. Now, I'll mark this up so you understand. This on a legacy chip is mandated here. This location here and here, also 4. These are mandated. You can't change them. Your SDO has to go here. Your clock has to go here. And if you had an SDI, which is serial data in, it would go here. You can't change it. The rest of them, like the reset, the chip select, or the data or control, these 4 lines here, 3 lines here, sorry, can go anywhere. I happen to pick the C port. So that is the difference between a legacy chip and one of the newer ones. On the newer chips, you can move the SDO and the serial clock around. But for clarity, we're locked into here. So what is SPI? So it's a serial interface bus that sends information between your PIC, your microcontroller, and other devices. An SD card, a storage card, is SPI. This works very fast. And this is more robust in terms of its communication than serial that we saw earlier on, or UART. And you see this an awful lot in GLCDs and shift registers and other sensors. SPI is very common. It uses separate lines for data and clock, along with a select line and other lines. So you've got clock and data lines. I'm only using one data line as a data out from the microcontroller of the controller, but I'm going to use a chip select to select it. So I could have multiple GLCDs and just change the select line and just change the select line, and I could pick one of many that are attached. The rest will just ignore the signals. There are other lines in this particular solution, but they're very specific to this implementation of this particular GLCD. So to be clear, there is separate clock, separate data in, separate data out, and typically a select line, also called chip select. It looks something like this. How many lines have I got on here? 1, 2, 3, 4, 5, which is what we saw before because I'm ignoring the 5 volts and the ground. So what I've got is a S. Let me have a look at what's written on that little picture there. Erase all the ink. SCK, which is the clock. Serial data A. Ooh, we'll have a look at that in a minute. Reset, a data or a DC and CS. DC meaning data or command, and chip select is select me, I'm the one. But let's look at this SDA. Go back a slide. There has been a change in the specification in this particular SPI protocols. They used to be called SDA. SDA is essentially data out. So sometimes it will say data out, sometimes it will say SDO, sometimes it will say master out, slave in. There's different names. It has changed. But SDA is essentially, SDA here is serial data in. There is no data out though. Okay. The setup in GC Basic is quite simple. You just need to define where the data out is on the clock and define these lines, which is the DC, CS, and reset, which is the chip select. So I've selected those, and they're all on the same, on port C. So data out, which it will connect to the SDA. The reset will connect to the reset, DC to the DC, CS to the CS, finally SCK. And I always use yellow and blue, and I've said that many times. Choose what color you like. What does it look like in my particular implementation? Well, let's look at, this is my board. This is my board. This is the GLCD right down here. It's tucked down here. Look. If I push it across, look, no, down there. Look. Great board, has great capabilities. Now I've got it connected into this rail here called the pigtail rail, and there's some wires coming across. So why don't I show you what that looks like? I took a photograph of the side, and this is my clock line. This is my serial data out, and these are my other three control lines. I can't remember what they are because they're on that previous diagram. So one C0 is DC. That's the DC line. That's the chip select line. Therefore, that is the DC line. And I just pushed them into here. That's adequate for what I'm doing. That's adequate because you're not going to be able to see very much on that particular desk cam. That little camera down there. We'll have a look and actually see how fun it is. Okay, we'll have a look what comes up on that display. So sometimes there is no, it doesn't work. I mean, it just doesn't work. Please don't phone me or just look at this slide and work your way through it. There is no SPI discovery. You either send the data or you don't. There is no way of knowing what's attached. Things do not always work. More connections, more trouble. I've got 5 connections on here, more trouble. That means it's not like we saw on I2C with just the two connections and the protocol looks after everything else. This is likely to be a connection problems. There are certain things we do know is that the demos work. Therefore, it's not likely to be in the GC Basic libraries, but work through this checklist and we'll figure out whether it is. And it's very rarely a problem in the libraries, very rarely. So checklist, check your connections and do them again. I had last week a guy who was contacting me extensively, and I kept saying this has to be a local problem. And then eventually he said, yeah, I hadn't actually got it wired up properly. So do check your connections. Then take away our program, our GLCD program, and write a little program just to pulse each line and go, right, pulse the data, the serial data outline without any libraries, and just get an LED on it. Make sure it's working at the GLCD. Do each line at a time, 1, 2, 3, 4, and 5, and make sure they're working at the GLCD. And you should always use Software SPI to prove your connectivity. If you've got a problem, just use Software SPI because you're not using the hardware inside the chip, and it will still work. It will just be a little bit slower, but it just proves that all your connections are correct. And then get in contact with us if you've got an issue. So let's go into some code and see what we're going to have a play with. Right, I'm going to go into the IDE. I'll shut everything down so we can just start. I'm pressing Control B, or you can take the Explorer at the top and pick. Let me have a look. It must be 230 SPI GLCD using an SSD 1331. Control B to get rid of that. The header is the same, apart from the fact I've updated the documentation here. Everything else is the same. I'll zoom in. Everything's the same. All the meat starts in the main program. We saw this before. Include a glcd.h, a library, and the type I'm going to say is a type of SSD 1331. If you want to see all the types, just go to the help. Now, because this is not a PPS chip, there is no need for PPS, but you have to put in the data out and the clock line SCK, and they're fixed. You can't change them. And that matches what I showed you in the PowerPoint. And then the other three you need to put in is DC, chip select, or CS, and a reset. Those are the 5 lines the library is expecting. Then you've got a couple of other little things. You can pick Hardware SPI or Software SPI. I've got it set to hardware. In actual fact, we'll take that out. We'll take that out. We'll take these 2 out and see if it still works. Shall we? We'll take that out. Just comment out those and we'll come back to that. And the rest of this program uses the primitives to put some stuff on the screen. Now what I'm going to do, I'm going to change my screen so you can see it. That is the IDE, the full extent of the IDE. Press the function key F5, it is programming it. Whilst it's doing that, I am changing the camera. If this works, it'd be a miracle. Hey, look at that. Oh, where's the camera? I need to turn off that lab camera and turn that one on. Look, I've got them a little camera. It's a little tiny camera. No, it's not brilliant. I admit, okay? It's not great. It's the best I can do, all right? Let me just change this camera. Can I do that? I can't. I don't think I can do that. Let me sort that out. Let me just change that camera. Copy. I'm going to put that and paste that into there as a reference. Oh, genius mode. That's the camera there, isn't it? That's that camera. I've done it. So now I've got the LCD on at the same time. If I press the reset button, we played with the reset in previous videos. I'm just pushing it. Here, 2025. That's some text. That's clear to blue with text. Rotate with some on red. Back to the blue. Rotate and red. And we're working in software here. We are using Software SPI. Seems to work, doesn't it? Seems to work. So if we come into our program, because that's what we changed, if I just uncomment those two, we're going to change it to Hardware SPI. And the difference is that when we use Hardware SPI, we're putting it into a buffer, and that buffer is then handling the communications on the data lines and on the clock lines. You won't see much difference, to be quite frank. Just seem a bit snappier. I'm sorry about the strobing on the camera. There is very little I can do about that. It's a bit faster. Now on my screen here, this is going different colors. You just don't get to see them on the camera, unfortunately. But look, you've got lines, circles, text, long numbers, bytes, words, you name it, strings. It says it's running at 32 megahertz. It seems to work quite well. Works very. Oh, I'm so sorry. It works Oh, sorry about that. It works quite well. So, and you can see here I've got the connections, ground, VCC, etc. And if I just push it, as I push the camera back up, you can see there's the connections I've got. It works quite well. This is demonstrating SPI. I'm not necessarily showing it's a GLCD, that's fantastic, yeah. But the concept here is actually showing the communication and how the library supports that. Let's go back to the screen and just the code. I'm not going to go into too much in here about GLC commands, all the stuff that's in blue, fill box, etc. The important one is in a legacy chip, your data out, data in, which is not used in this particular solution, and clock are locked to particular pins. They are C5, C4, C3 respectively, and things like the data or command or DC line CS and the reset are all can be put anywhere. Okay, I'm going to take that comment out. It should say hardware SPI. It's nothing. Sorry, it's nothing. There's no PPS in this. It's just quite simple. Is there anything up the top? No. Beautiful. Very, very simple. SPI. Let me just go back into my slides. So we just looked at software, bit banging, some hardware, SPI, and conditional compilation. Now, why is that in there? Oh, I can tell you why. These here that I commented out, determine what happens deep inside the library. The library will make a decision to use the hardware routines or the software routines, and it's called conditional compilation. So that line, the definition of that constant determines which part of the library at the low level is used. Is there any other conditionals in here? No, that's what I needed to point out. Thank you for reminding me, PowerPoint. So, where to next? Where to next? Pulse width modulation, many ways. We've got 4 LEDs. We're going to learn to dim the LEDs slightly differently using pulse width modulation. Enjoy.